Google Cloud Functions are serverless code functions that listen for and respond to events in the cloud. For example, a function could listen for a file uploaded to cloud storage, listen for a log change in Stackdriver logging, or respond to mobile app events from Firebase. This event-driven model is different from many traditional applications that are composed of services that must be explicitly invoked before they take any action. Today, we'll create a cloud function that listens for a file upload on a cloud storage bucket. Processing a file is a common scenario, and you might take a microservices approach where your application uploads the file and then calls an API to perform processing. In a Cloud Functions world, this looks a little different. Your application uploads the file, and that's it. Google Cloud recognizes that a file create event has occurred and automatically invokes your function. No need to create an API endpoint or worry about managing or scaling your API depending on load. Because Cloud Functions are serverless, scaling is automatic. So as the volume of events goes up and down, our functions scale transparently, and we're only billed for their actual execution time. In fact, if you had different types of processing you'd like to do on the same file, instead of chaining them, you could create two Cloud Functions and have them process in parallel, both triggered off the same file upload event. Let's take a look at what happens when you upload a file to Cloud Storage Bucket. After the file is uploaded, your Cloud Function is invoked and a JSON payload is passed into your function that contains details about the file, things like timestamps, whether it was a create or delete event, and the location of the file in cloud storage. Let's code an example. We'll use an image for our file, but this would also work for files with structured data. For example, when a CSV is uploaded, a Cloud Function could automatically run and do some lightweight data transformation, and then save that data to a database like BigQuery or Cloud SQL. Here's the skeleton of our function, written in Node.js. Cloud Functions can work with callbacks or promises in JavaScript. Here, we're going to use promises, so our function has one parameter, event. Event contains some metadata about the cloud event, such as the event type. In this case, it's a file creation event in cloud storage. The structure of event.data changes based on the type of event, and here we see the JSON that represents our file upload. We'll do an image analysis using the Cloud Vision API, which will generate labels that describe our image. Notice that we're calling the Cloud Vision API without supplying an API token or a service account. That's because Cloud Functions are automatically authenticated to your other Google Cloud APIs, which makes it really easy to access your Google Cloud resources. Once we get a response from the Vision API, we'll extract the description and vision score from the API response and save the results into a BigQuery database. To deploy our function into the cloud, we run the gcloud functions deploy command and specify two buckets. One bucket for Cloud Functions to watch for file changes, and the other to store the source code we're about to upload. gcloud packages our code up for us, and Cloud Functions builds and compiles our node modules in the cloud. Now, I've been developing this Cloud Function using my normal development workflow. There's an open source functions emulator you can run locally, and it includes a debugger hook so you can continue to develop using the editors and debuggers you normally use. After the function has deployed, let's see it in action. I'll manually upload a photo of this adorable raccoon into cloud storage, which will automatically trigger our analyze image function. Once it's finished uploading, we'll switch to the BigQuery database and run a SQL query to see what the Vision API had to say about our image. We see the Vision API has returned raccoon with a high confidence. Very cool. That's how easy it is to create a Cloud Function that listens for file events on a storage bucket. Cloud Functions has a free tier, so it's easy to get started. If you want to learn more, check out one of the other videos or go to cloud.google.com/functions. Thanks for watching.